And hello out there for those of you watching. We'll be starting Developers Let's Code soon. So please come and join us. We'll be looking at relational databases this week. So we'll just give a bit of time for people to come in and join us. If you're watching me, would love to hear where in the world you are calling from. Hey folks. Excellent. We are live. I have confirmed we are live. That's always a good thing to know. So in a few minutes we'll be starting Developers Let's Code. And this week we are looking at relational databases on AWS. So a great primer for those of you who are maybe a little confused about the different database offerings on AWS. We'll be diving in this week on relational databases. And next week we'll be looking at the non-relational databases on AWS, of which there's actually quite a few to choose from. So if anyone's out there, please let me know where you are viewing from. Would love to hear from you, and we'll get going in a few minutes when things begin. This is the nice relaxing time while we wait for a few people to join. So if you're just joining in, welcome to Developers Let's Code. This is a Series A issue, good in Sydney. I'm also from Sydney. My name is John. I'm a developer advocate at AWS here in Sydney, where it's almost summer and it's almost winter. We're not quite sure what time of year it is. LA, DNG, good to have you in from over there. What early evening for you, yeah, evening for you there. Texas, fantastic. Whereabouts in Texas? I had a lovely trip one time where I went to San Marcos. There's San Marcos. There's a great Amazon distribution center in San Marcos that I spent some time in. Visited San Antonio and the Alamo. Did all the touristy things out there. It's always cool. So thanks for joining, folks. We'll be beginning soon on Developers Let's Code. In the meantime, let me know where you are viewing from. Always like to see you. Costa Rica. Oh, Costa Rica. I always like, to you, Australia is probably an exotic destination, but to me, places like Costa Rica, Bermuda, all those places are lovely. Fantastic. I haven't had the pleasure of visiting South America really, so one day we'll get to do it. Fantastic. Toronto, let me say it right, Toronto, if I said it right. One of my favorite streamers, since you like watching Twitch, is a fellow called Hitch. And Hitch normally travels the world hitchhiking, but in these conditions he has taken up cycling across Canada. Recently did a 70-something day cycle across Canada, which was quite nice. San Francisco, I recently played Watch Dogs 2, which was set in San Francisco, so I love the city as well. So, probably time to begin. So feel free to keep throwing out locations where you're from. Love to hear from you. My name is John Rotenstein. I'm a developer advocate at AWS, and this is a show called Developers Let's Code, where we target it at developers who are relatively new to AWS, who are starting their journey with AWS, or you've used a fair bit of AWS, but you don't understand the full breadth of it. Phoenix, I've been to Phoenix. We go through services and give you the essentials of what you need to know about our range of different services that are out there. Phoenix, I love Scottsdale out there. Turns out Phoenix it was closed on the weekend when I was there, but Scottsdale was a lovely place to visit. Today we've got this show here, Relational Databases on AWS, and next week we'll be looking at no SQL databases. Hey Dennis, good to see you. So next week we'll be looking at non-relational databases, but this week we'll concentrate on relational databases. And there's this handy page, I'll throw it in the chat for you, which talks about the AWS database offerings. And boy, there's quite a few. If you look at this page here, we'll be concentrating today on the relational databases. So Amazon Aurora, Amazon Rds, which is our relational database service, Amazon Redshift. I'll also talk a bit about Amazon Athena, which is more of a query engine than a database, but I like throwing that in as well. And next week we'll get to look at some of these other services like Dynamodb, which is the Amazon Dynamodb is a NoSQL database service that provides fast and predictable performance with seamless scalability. So says our marketing page. It's basically a fully managed NoSQL database that can do incredible stuff, and you just start using it, it's always on. Elasticache for caching, DocumentDB, which is if you like Mongo, Keyspaces, which is if you like Cassandra. We've got a graph database, a time stream database, which is fairly new for time ordered data, and the Quantum Ledger database, which is all about being able to prove that the data in the database has not been modified. A proxy, good to hear we're talking about cloud managed databases. That's it. If you've ever tried to install a database yourself, you will realize the frustration involved with databases. But none of that today. We will use databases in the cloud. So the first service we should really play with is RDS, our Relational Database Service. And this has been around for a long, long time and is very solid and is continually adding new capabilities. And this is all about, hey, you want a database, you want somebody else to provision it, to make sure it's running, it's updated, it's backed up. You can monitor, are you running out of space, potentially automatically add space. So think of RDS as your operations team, your database operations team in the cloud that you don't have to employ. So really great option there. So the best way to understand it is to play with it. So Proxy says, as a DevOps engineer mostly running containers, DB workloads are something I don't want to manage. Correct, you just want to get on with what's needed for your developing. You want to use a database, you don't want to have to run the database. So if we hop in here, the first thing you'll notice is we have a number of different database offerings. We have the biggies out there. We have Oracle and Microsoft SQL Server. If your business is tied into using some of these databases, then we can certainly support that. There are various licensing options I should point out to you as we do that. For Oracle, it tends to be a bring your own license, but it varies based upon the type of database you're using. For example, if you are using Oracle Standard Edition 2, we have an option called license included, which means the hourly cost covers the cost of the database as well. If you're using Microsoft SQL Server, they recently changed a lot of their licensing. I won't get into that too much, but they no longer let you bring your own license to the cloud. So instead, when you use Microsoft SQL Server on RDS, we will bill you the total cost of running the database and the database license, which for many people is a lot simpler. However, we like to encourage a lot of our customers to get a bit of freedom and move across to systems that don't lock them into particular vendors. So we have some options here. We have MySQL. For those of you who know the background of MySQL, it's not actually called MySQL, it's called MeSQL, because the creator of MySQL has a daughter whose name is Me. But it's written MY, so lots of people like to call it MySQL. Hugely popular open source database. It was bought out, well, sort of Sun took over it as an open source database. Oracle then bought out Sun, and therefore the world's biggest open source database was owned by Oracle, which led to a lot of confusion and angst and things. So the creator of MySQL forked the project and created another one called MariaDB. The creator of MySQL actually has a second daughter. Can you figure out what her name is? It is in fact Maria. So the two databases are named after his daughters. And MariaDB is sort of like MySQL, but it's forked off. True open source, it's been put in a foundation, it will be free forever, or open source forever. PostgreSQL is actually my favorite. It's an enterprise grade open source product. It is open source. There's a PostgreSQL company that runs it, supports it, etc. But it's a community driven, very good quality enterprise scale database. And then we have Aurora. I'll talk about Aurora in a moment. Aurora is AWS's take on what you can do with a database in the cloud. Really, really cool. Thanks up there. So let's begin. Let's say I was launching a PostgreSQL database. Postgres is named after Ingress because Ingress used to be a popular database, and the opposite of Ingress is Postgres, so that's why PostgreSQL was called that. So when you go to launch a RDS database, you can choose the version that you have. We have a fair library of previous versions, which are hopefully compatible with what you've been doing. By the way, for those of you who just joined, my name is John Rotenstein. I am, what's this console doing here? I will show it there. Just to recap briefly, you are watching Developers Let's Code, which is a show aimed at fairly new to AWS developers who try to learn what are all these AWS services. This week we are looking at relational databases on AWS. Yeah, egress, Postgres. I'm just telling you the story of proxy. I'm not too sure about the naming. And we are launching an RDS database to see what it's all about. So there is the database version. We then say, hey, what do you want to launch? Do you want to launch a production database? Big server, running across multiple availability zones. I'll talk about that. Do you want to run a dev test system, which you don't need as big, you don't need replicated data, but you want it to work fairly well? Or do you just want to try things out on the free tier? So we generally ask these options. You can name your database, give it some login credentials. You can then choose the size that you run on. So RDS is not serverless. We provision a server under RDS for you. We then install the database and run the database for you. So you can choose the size of the instance, which will give you a certain amount of CPU, a certain amount of RAM, and speed of disk storage. Elastic Block Store, EBS, is the disk storage. You can choose how much you want. So you choose the size of machine. You choose how big you want your disk storage. We have a few options available here. Provisioned Iops is where you can crank up the speed of the disk and get really, really good performance. Most databases die because of slow disk performance. So using provisioned Iops, you can literally tell us how fast you want it to be, up to 80,000 Iops. Additional charges do apply. So if you're just doing dev tests, no need to turn that on. But for production, definitely have a look at that. We now have a feature called storage auto scaling. And what happens here is if you are running low on disk space, RDS will automatically predict how much disk space you'll need. Oh, you're running low, let's say less than 10%. It will add a certain amount, which is either 5 gig or 10%, whichever is greater. When you auto scale, it won't auto scale for another 6 hours. So it can actually figure out how much storage to give you to last you at least those 6 hours, so you can keep going. Really, really good, because I've been involved in many companies and they walk into work one day, the system is down because the database is out of storage space. So storage auto scaling is really neat. Multi-AZ, this is what I mentioned before. So in multi-AZ, let's see if I can come up with a nice picture for you. Multi-AZ is where you run across multiple availability zones. And third party, that's fine. And the idea is RDS actually provisions two databases. It provisions a master database in one availability zone and a standby database in a second availability zone. The master database is running, all your data is storing it, you are connected to the master database and you are running it. But behind the scenes, the data is replicated between the two of them. So the standby database instance is not running, but it's got a copy of all the data. So if anything should go wrong with your master database, RDS will recognize that. It will turn on the standby database. Only takes a minute or even possibly less. The data is already there and you can continue. And you might have heard of things like RPO and RTO. These are concepts about how much data you lose if you have a system outage. So the concept is recovery time objective is how long it takes you to get going again, so a minute or two. And the recovery point objective is how much data you might lose in case of an outage. Got a question here, do we have serverless Postgres like MySQL? No. So Aurora Serverless, that I'll get to, is only available in MySQL at the moment. And that's a really great option to have as well. What was I saying here? So recovery point objective, how much data do you lose? So in the case of a multi-AZ database, you don't lose anything. The database might be have an outage for a couple of minutes, but then you connect to it, all the data is there, you keep going, and you're fine. So really, really great way to operate by having that master and standby. It does cost you twice as much though, because we are literally running and provisioning those two databases for you. So for Production, we highly encourage multi-AZ. For dev test, no need to worry about it. You can choose which VPC, which subnet, etc. you put your database into. You have full control over that. You have the option to make the database publicly accessible. And this means it gets a public IP address and it can be accessed from outside your VPC. Normally, you don't want that for a database. Your database contains confidential information. Do not make it public. However, there are some use cases. For example, you might just want to be playing around with RDS, as I will in a moment, and you want to connect to the database from your own machine. You can then make it publicly accessible. If it isn't publicly accessible, the domain name will not resolve to a public IP address, so you literally cannot connect to it. Does AZ cross-region? So the multi-AZ option is always within the same within the same VPC, and therefore in the same region. There is an option in Aurora to go multi-regional. There is also the ability in RDS MySQL to do a read replica that is in a different region. And the nice thing about that is you can have a read replica in a different region. You can then promote that read replica to a master database, and you can literally copy your database that way to a different region, have it replicate, and then have it create itself as a standalone database. So a couple of worldwide options there for databases. Authentication. You can do traditional database logins with a username and password. You can also activate IAM. So if somebody has IAM credentials, they can use that to log into the instance, which is fantastic because it means you're only handling one set of credentials in one location rather than saying, oh, this user can do EC2 things, but if they want to use RDS, they've got to have this other sort of password. And when they leave the company, do you remember to turn it off? So you can go for that. You can also use external directories to do authentication on RDS. Backups. So RDS will automatically keep backups for you on a continual basis. In fact, backing up your database, for the size of your database, there's no extra charge. So you get one backup effectively for free. And we can retain the data for up to 30-ish days, 35 days. You can also create a manual snapshot whenever you wish and keep that as much as you want. So maybe you'll do a weekly snapshot and keep it for 6 months type thing. So the nice thing about the automatic backups is, let's say you've accidentally deleted some data, you can go back to one of those backups, one of those snapshots, and say, please restore this database as this snapshot. It will create a new database with the data as it was at the time of the snapshot. You can then copy that data out and restore it to your existing database, but it creates a new one, which you can then connect to. We also support encryption in RDS, so encryption at rest, which you can use our KMS, Key Management Service, to encrypt your data. And you can choose the keys that it's using. Performance Insights is a very detailed logging of the database. If you find you are having performance issues with your database and just general metrics like CPU and disk isn't enough, you can turn on Performance Insights and you get a lot of detailed information. In fact, you get that for 7 days, but if you want to retain it over a longer time, additional charges apply. You can choose the granularity of the normal monitoring. Normally, every minute getting your CPU might be enough, but maybe you've got different spikes, you can grab that. And finally, RDS will automatically do maintenance for you. So if there's a minor version upgrade that comes out, you can say, yes, I'm happy to do minor version upgrades. You can select your particular maintenance window, or we'll select it for you, and we'll automatically perform those updates for you. The nice thing is if you are running a multi-AZ database, then we actually perform the updates on the standby database, flick you across, and then update the original master database that's now your standby database. So there's no outage time when doing upgrades on a multi-AZ database. Works really, really nicely. And one thing I love down here is we show you what the cost will be. So if I am choosing, let's go all the way back up here. If I'm choosing a production database on a really big server, let's say I've got a R series server, which is memory optimized, which has lots and lots of RAM on it. I'm going to choose this one with 256 gigs of RAM. and I jump down the bottom, it's saying that'll be $7,000 a month. Don't freak out, that's 2 databases of a very, very large size. If you are just doing dev test type operations, then you could do burstable instances. Burstable instances, our T family, allow occasional bursting of CPU, but don't do it forever. And the costs can be quite reasonable. It's saying now that would only be $23 a month. So make sure you use the right size database for your particular need. You can always change the size later by modifying the database. Is there a minor version upgrade on any new releases or AWS recommended version? My mic gain is very low. I will talk a bit higher here and try to yield to you. Thank you for giving feedback there. So the minor version upgrades are the ones that are released by the vendor. In this one, we don't have a particular track. I know in Aurora and Redshift, you can change things, so you can say, do you want to be on the latest release? Do you want to be on the trial release, etc.? But this is based on minor versions from suppliers. If you want to go for a major version upgrade, you've got to specifically trigger that yourself. We will not do a major version upgrade because that tends to break things a lot more. So I happen to have created a database earlier, and this is a multi-AZ database, hopefully. Yes, I've got the multi-AZ database option turned on. I also have it publicly accessible, which means I can connect into it. I can do that a couple of ways. This is Postgres, so I could use PostgreSQL, PSQL command line to connect into it. There I am. Or you can, of course, use a SQL client, which I've configured to connect into here. And I can run similar commands here. So let's try a few things with this database. I might create a table with name of text, and I might insert into that table my name, John. And what have I got here? If I spelt it right, it would be good. Insert John, and I will also insert your Simba. So select start from foo, and I've got the names in there. So the database is working quite correctly. Let's try something here. I haven't done this for a while. I can come into the database and say, or can I get it going? Restore, reboot. So normally I can trigger a failover. If they move that option on me now. Does the reboot do that? IDS force failover. Rebooting. When you force a failover of your RDS database, so if it's configured with multi-AZ, you can perform a reboot at events created. If your database is multi-AZ, you can force a failover from one availability zone to another when you reboot. So let's give that a go. I will come in here and say, reboot. Do we know which AZ we're running in here at the moment? I'm running in availability zone B. Keep that in mind. And I say to the database, please reboot with failover. So this will cause it to simulate a failure with the master database. It will flick me over to the standby database. The URL that I'm using to connect to the database, the DNS name will remain the same. So it's just a matter of when I connect, it will send me over to the other database. So let's see if, so my existing connection has failed, which you would expect because the database server has gone away. Whoa, it's really not wanting me to get out of that thing. And let's see what happens if I try to connect in again now, and it's done it. I've connected back into my database. If I refresh the screen here, instead of being in zone B, we should see that is flicked over. It's my replicas. security group. That's interesting. Oh, I'll tell you what I did. When I set this up, I didn't create a database subnet group. I have a default subnet group there. Oh no, this default subnet group has 2 availability zones. Not sure what happened there. But you saw the speed. When I caused the failover, my existing connection was lost. Once I reconnected about 30 seconds or a minute later, it connected in and I successfully got it, and all of my data is still in there. So that's our base RDS offering. I made a mention earlier about Aurora. And Aurora is AWS reimagining what a database should be. So the general, maybe came back too quickly, that could be it. Databases are always getting better, but the core way they are designed hasn't generally changed over the decades. And now that people have moved to the cloud and things are different in the cloud, this was an opportunity for AWS to rethink, hey, what can we really do with a database? And to give you a bit of insight into the way Aurora works, traditionally, a database, let's say, have a master and secondary, they're replicating between each other, they send lots of data out to disk. Disks might get replicated because you want to back up your disk and not have data stored in only one location. There's an awful lot of data moving around. And the nodes, the compute nodes running the database, are very closely tied to the storage nodes because they manage all of the storage and the way that data is stored there. And what Aurora does is it steps back and it says, hey, let's separate the compute, the database engine, which is either MySQL or PostgreSQL, so same front end that you used to connect to it, looks just the same. Let's separate that from the back end. And instead of pretending to be traditional disk volumes, let's totally change the storage architecture for the back end. And the way it works is that Aurora has 6 storage units. And you can see them here. When the database gets some data, it goes out and it sends it to 6 different storage units, each in 3 different availability zones. And as soon as 4 out of these 6 come back and say, thank you, we've written the data to disk, Aurora can continue on and go and do more things. So 4 out of 6 means you might have 1 availability zone that has failed. That's all right, there's still data in 2 availability zones. Maybe 1 or 2 of those storage nodes has failed. It's all right, we still have at least 2 availability zones and at least 2 copies in those availability zones. So we have at least 4 copies. And it doesn't update the database, it just updates the log. It's a really interesting way of doing it. And if you want more details, we've got some fantastic presentations on YouTube, but this is a great white paper or blog post talking about it. And here we can see the different storage nodes across the availability zones, each within 10 gig blocks. And by the way, Aurora automatically expands as you store data. You don't have to do anything, it will automatically expand out to the maximum area. You have 1 or more compute nodes talking to the storage nodes going across those 6 storage nodes, and the data gets backed up to S3 as well. So if any of those availability zones should fail, it still has 4 nodes. If any of the storage nodes within the availability zones fail, it can continue operating read-only with at least 3 nodes, but to do writes, it needs at least 4 of those nodes to guarantee your data is replicated enough so you don't lose it. So some really interesting information about how Aurora itself operates. So Aurora is really, really good for write-intensive transactions. Traditionally, writing a database is very slow, but Aurora, it stores the transaction log and then uses that to convert into pages after the write has been committed. So really good for write operations. Very good for read operations too, because the data is replicated across these multiple storage nodes. It can connect you to the closest storage node, and multiple nodes are running, so it can provide read access very, very quickly as well. And the nice thing is, because the data is kept separate to the node, if you have a node failover or you add an additional read replica, there's no time required to replicate the data because the data is already replicated. You are just adding additional compute nodes, which is really good. Yoshimba says, how difficult is it to scale up a cluster in case of large fleet exhausting all your connections? So you can add additional read replicas. So both RDS and Aurora handle read replicas very nicely. Traditional application workloads are very read heavy, so you would tend to you can create a read replica endpoint, which will then distribute across multiple endpoints. And then you can just point to the master node for your write workload. So that's a great way to scale up. Aurora is very, very fast for adding additional capacity simply because the data is already there, it's already replicated. And somebody earlier asked about this other option, which is Aurora Serverless. So I can come in here and say, I would like a serverless Aurora. And you'll notice the options are very simple here. It's like, what are your login credentials? What's your minimum and maximum capacity? So there are capacity units that assign a certain amount of compute capability and RAM to the database, but Aurora Serverless will automatically scale out and scale in, well, it's actually up and down, to provision that. And this is really good for intermittent workloads. So maybe you're doing testing during the day and you're doing nothing at night, you can automatically turn off at night. If you they give an example. Maybe your application is very busy when it rains because people are calling for rides in their car or something like that. It can scale very quickly to handle those bursty workloads without you having to predict when that will happen. And there is very, very little other things you need to do with Aurora Serverless because Aurora takes care of it all for you. So really, really great option for bursty or intermittent workloads. It's like the Dynamodb of relational databases. So that is a quick overview. A few other things I want to mention for let's see, read replicas. Oh yes, I want to show you this diagram here I was talking about before. You can see how the replication goes across those multiple nodes. The main thing is that the data is written to the log. Once things are written to the transaction log, Aurora can continue operating, and it then later on transfers it to the data storage and out to S3. So very, very clever operation. Runs about 10 times more efficiently than a traditional relational database. So really good option. Do consider using that. Can there be syncing issues across read replica storage with on-demand services or heavy API transactions? So in Aurora, the replication is inbuilt into the storage layer, so the read replicas simply point to their local storage. So no problems with synchronization with Aurora. It will only acknowledge a transaction once it has been written to those 4 storage nodes, and then it will allow you to continue with your later transactions. So no sync issues because the replicas are already there. In RDS, where you've got separate read replicas, yes, there will be a traditional delay for replicating your data to other nodes. If they're in different availability zones, they're quite fast. We have low single-digit millisecond latency between availability zones. If you're replicating an RDS MySQL across to a different region, that would of course have further delays for transferring data internationally. Heavy API transactions, the serverless will automatically scale based upon your CPU and number of connected users. And the other databases, it's sort of up to you to rescale your database if there is a very heavy load, if you're running a traditional relational database. So keep an eye on those metrics, create some alarms, and then you can scale out both the storage and the compute nodes out there. And there is a bit of a delay because we've got to fire up a new compute node for you. We then flick across the data storage. Any existing connections, just like I had, will be disconnected, and then they'll be reconnected to the new RDS database instance that is running. Any other questions there about RDS? For those of you who just joined us, my name is John Rettenstein. This is Developers Let's Code, where we are talking today about relational databases. And next week we'll be talking about non-relational databases, of which there is quite a few out there on AWS. So any other questions at the moment about RDS, Aurora? I should point you to some really great YouTube presentations if you're interested. Anything on, this is a good one, anything about Aurora from reInvent is a great way to learn about the background. Have somebody who wrote it explain it, which can probably be better than me. Is there a drawback to using Graviton instances for RDS? They seem to be cheaper and more powerful than x86. Oh, that's a really interesting topic. Thank you very much, Magnum. What's new? AWS Graviton. So Graviton are relatively new chipsets that we've released. They are based on ARM architecture, which Apple is also moving to. And these are designed by Annapurna Labs, which AWS bought out, and they've been designing our chips for things like the Nitro instances. They take care of all the virtualization of our EC2 instances. We run on custom silicon there. And we've recently introduced the M6 and the T4 series with Graviton processors. Compute and all that as well. So you might have noticed in this thing, if I said I want to use MySQL and I want to choose the instance classes, there is these M6G, and that means Graviton processor. So because it's an ARM-based rather than x86, anything you run has to be compiled for that chipset. So plenty of operating systems out there, Amazon Linux, Red Hat, etc. you can get for that chipset, for the ARM chipset. Applications you download, you might have to get the particular version for ARM. For example, if you install the AWS CLI, there's an ARM version available for that. The nice thing here, however, is we've taken care of all that for you. The fact that we offer you MySQL running on RDS using the Graviton means we have tested the database, we've compiled it, we know that it is working very well on that chipset. So definitely go for it. It's more powerful and lower cost, or whatever combination you want, and it works. So I would highly recommend you look at the Graviton instances out there. We don't want to spend too much time going to pricing for RDS, but let's have a quick look at the general way that it works. You can have single or multi-AZ. Multi-AZ has that automatic second instance for you. The price is twice as much, makes sense. So you pay for the size of the instance that you are running. You also pay for storage. In this case, a general purpose drive, 11.5 cents per gig, similar to our standard EBS, or you can go for provisioned Iops, which has an additional charge based on the speed of your disk. So you basically pay for the size of the machine, which has a certain amount of CPU and RAM, and the storage. You pay for the storage that you allocate. So if you say I want 20 gig, you start paying for that 20 gig straight away. You can then expand it later on. Can you talk about Aurora Global Database? Is it really multi-master DB, or is it one primary global and gets replicated? What is cross-region replication lag? So our Aurora Global is so new, I haven't had a chance to play with it. So I don't want to say the wrong thing. I would point you to the documentation that we have and the videos that are out there now talking about it. I don't want to give you the wrong information. But yeah. Basically, it allows you to suffer the loss of a region. A traditional RDS database is running in one region, while you can have a replica elsewhere, it's really one region. This one gives you the ability to have running across regions. I think it is effectively multi-master, but please don't quote me on that. I haven't had a play with it yet. Thresholds have additional readers in Aurora cluster. So I mentioned before that Aurora measures things like CPU, number of users connected. You want to look at the response time for your transactions. If your CPU load is the general one, if CPU load is too heavy, that's the time that you want to go and have another read replica to offload. Your storage metrics are a bit different with Aurora because of that replication, and it's not really going to impact your node as much because there's the 6 copies of the data. So it tends to be the CPU and RAM which would be impacting on the database. Get your normal DBAs. We love DBAs. You don't have to waste your time installing databases, maintaining them, etc. But DBAs are still very helpful for watching over the health of a database and seeing that, is it running optimally. Aurora, I should mention, has a slightly different pricing plan. Let's pick one of these. Again, it has a database instance that runs, and you can have read replicas that you would pay for. And there is, again, data storage that you pay for. And then there is Aurora Serverless that operates on a bit of a different concept. And let's see, Serverless. I had the pricing here somewhere earlier. Mysql Serverless, here it is. You have this mysterious thing called an Aurora capacity unit, which gives you a certain amount of memory and CPU. Think of it a bit like scaling an EC2 instance, and it's charged on an hourly rate. It can be a little bit hard to predict what you need because it will vary based upon your load. So it's not as predictable, but the nice thing is when your system is not being used heavily, it will scale in and reduce a lot of the costs. So if you have a database that is being continually used and is running heavy workloads, traditional Amazon Aurora will probably be a more cost-effective one. But if you have workloads that are intermittent and spiky, then serverless will typically give you a better pricing option and less management overhead as well. Whew. That's RDS, that's Aurora. There's another one that I want to talk with you about, and that is Redshift. Now, Redshift is not a database you would traditionally use for applications. Redshift is a data warehouse. So to give you a bit of an idea of the difference, a traditional SQL database runs on one server, and to make the database run faster, you've got to scale up that server or have read replicas, things like that. Redshift is more like Hadoop, if you're familiar with Hadoop, where it offloads and does work in parallel. So you have a leader node that you connect to with traditional SQL. Redshift is based on Postgres version 8. So anything that works with Postgres will work with Redshift, though there's some extensions to it. So you connect to that leader node, run normal SQL, but behind the scenes, it actually runs multiple compute nodes, and each of those compute nodes are separated into multiple slices, and each of those slices have storage, and it's all designed to be highly parallel. So a data warehouse, so a typical database, have you ever noticed how once you start getting like 1 million rows in a table, it starts to slow down a little bit? Redshift loves 1 million rows. In fact, I've had billions of rows in a Redshift table and it just keeps running. It's an amazing system that can run across huge amounts of data in parallel very efficiently. And it does that in a couple of ways. First of all, it can distribute the data across nodes. So you can nominate a column in a table, such as a customer ID, and say, please distribute my data based on the customer ID. So every record to do with a particular customer will be on a particular node. So when you join data together, it's all co-located. But each node works in parallel. So several databases can effectively be collecting the information you want. It also has something called a sort key, which tells it within each cluster how to store the data. And Redshift stores in its columnar database. So everything for each column is stored separately. This means it can compress the data, which is very efficient. If you have a column of, say, numbers or a column of text, it's very efficient to compress that same sort of data. And I mentioned before that databases slow down when you use lots of disk access. So anything that's compressed will use less disk access, and therefore the database will run faster. Also, each block on the disk has something called a zone map, where it says this block contains records 1 to 100, or Smith to Tracy. So it effectively says this minimum and the maximum value stored in that block for that column. And that means when you use a where statement, you go out and say, find me a surname where the surname is Sampson, it can quickly skip over those disk blocks that it knows does not possibly contain Sampson. And when it finds a block where Sampson does fit within that range, it can then read that block off disk and process the data. So one of its best assets is being able to totally skip over reading data on disk. And the result is phenomenal, really, really fast for running read-heavy queries. So when to use Redshift? Redshift is when you are typically reporting on data. So I used to be a reporting analyst, and I would extract data from lots of different systems, from my sales system, from my support system, from my customer service system, put it in here and run queries and say, hey, how much does each customer really cost us in terms of service? How many customers are in Australia? What's the average revenue we get per customer? And to do that, you have to collect lots and lots of data from different services. And that's really good for Redshift. Redshift is not good for OLTP, online transaction processing, where you are continually updating and doing things. For that, use RDS or Aurora. Redshift, you suck information in from other locations. You can perform some transformation, but really, really good for reading. Nata, you ask, Nata, is there an option to migrate from traditional Aurora to Redshift? That's very interesting. You should mention that. So AWS has something called a database migration service, which is just a tool which allows you to migrate, let's go to the documentation, between various different databases. So this is our way of saying, hey, let's make it easy for you to move into the cloud or to move between different database offerings. And it basically spins up a server that connects to your source database, watches that change data capture, watches what happens there, looks at your target database and starts replicating the data. So it'll begin by replicating everything, but you can actually keep it running and it will replicate data as it is updated in one database and replicate it to another database. And let's see, AWS DMS Docker Redshift, let's say. So I can come in here and say, what sources and destinations do you have within here? So DMS can read information from Oracle, SQL Server, Azure, Postgres, MySQL, Mongo, S3, DB2, and it can send out to similar databases. We've also got things here like Dynamodb, Kafka, Elasticsearch, and so on. At least one of these, the source or the target, must be an AWS provided service, but you can also use it to export your data, for example. So if you want to move from Aurora to Redshift, so we have Redshift as a target in the DMS service, and you can connect to effectively MySQL, which Aurora MySQL would present itself as MySQL. So yes, you could transfer your information that way. Traditionally, however, data warehouses, you want to have an ETL process, extract, transform, load, where you typically convert the information into a different format for your data warehouse so it is easier for querying. So while you could replicate into Redshift, you'll normally want an ETL process to clean it up, and services like AWS Glue can help you with that. This presentation, yes, it is recorded, GJJ. You'll find it here on Twitch and also on YouTube. We post the videos on YouTube. I'll give you a quick link. You can find the videos in my YouTube channel. So to give you an idea of what's happening with Redshift, I have a Redshift database hopefully up and running here. Yes, one that I've connected to. And let's have a bit of a play with it. I have a lab in Quick Labs. I don't know if many of you are aware of our offering. We have a number of labs available that you can run online. Some of them are free, some of them are chargeable in a service called Quick Labs. And Quick Labs has a lab all about Redshift. Here it is. And I'll just go quickly through this lab. It's called Working with Amazon Redshift, a really great way to become familiar with Redshift. And I'll show you some of its power just by jumping through some of these commands that it has in here. What I'm going to do is load some data into Redshift, and I'll explain what's going on as I run this. Woohoo! So I have just created a table called flights, and the database I've got has years and years of flight information from the transit authorities in the USA. And I'm now going to load some data into the database. Just got to grab some IAM credentials to do so. Fantastic. So the nice thing about Redshift is you can use IAM to authenticate accessing your S3. Cool. So this will take a few minutes to load my data. This information consists of, let me get this for you. Let's see. Okay, I am loading 96 million records into this flight table. And that's quite a lot of data to load into a traditional database. If you have a database with about 100 million rows in there, you probably want to think about splitting it off or using replicas, etc. Redshift can handle this quite nicely. It doesn't matter that it's 100 million records. It's currently reading it in from S3. The nice thing about reading in from S3 is that it can work in parallel across multiple nodes. My Redshift cluster that I've launched has 2 nodes running in there. And we'll have a look at some data in there once it's loaded up. While that's working, I should also mention Redshift has a capability called Redshift Spectrum. And Redshift Spectrum is a query engine that can work directly across your data stored in S3. So if you have CSV files or Parquet files or things already stored in S3, Redshift can query them directly without loading them into the database. You can even join data that is stored in Redshift against the data that is stored in S3. So you might have archival, historical data stored in S3 because it's very low-cost storage. You might have your latest hot data in Redshift, and you can join across both of them, very similar to our Amazon Athena service, which can also run across data that is sitting directly in S3. I'll mention that briefly as well. So here I've got some data I've loaded in, and we can see some information here in various years. This is some random data. Different airlines going between different airport codes, running across, let's bring that up, how many passengers did they transfer, how many pounds of freight, etc. So if I go in here and I say select count star from flights, we can see that there is 193 million rows. That's interesting. It sounds like it loaded the data twice. Not too sure why. Very, very fast for doing queries. So I could come in here, for example, and say, add up the number of departures for every carrier. And it just went across that 193 million rows and added up the information out there. Hugely fast. Doing this on a normal database would nowhere near run so fast. You can also join between tables. It's traditional SQL, really, really effective for getting querying massive amounts of data in normal SQL for powering your dashboards, your report engines, etc. We've got a few minutes left. I also want to talk about Amazon Athena. So Amazon Athena is a query engine. And this is where you put your data only in S3. I'll call out some things here. And it can query directly against the data that you've got stored there. And to give you an example, I have a blog post. And this blog post talks a little about Athena and how to optimize. And I'll give you a quick 5-minute overview of what it's basically saying of how Athena works. So Athena queries data in S3. And let me go to US West. You only pay based on the amount of data you scan from disk. So if you have a lot of data, you pay for it. But there's ways to reduce your costs in Athena, and it's really, really neat. And to give you an idea of that, excuse me, I'm just grabbing my cheat sheet here. So I have some CloudWatch logs sitting in S3. And what I can do is I can tell Athena, please create me a table. And this is pointing to my, sorry, not CloudWatch, Elastic Load Balancer. This is pointing to my Elastic Load Balancer logs. And it's saying my data is stored in S3. Here is a definition of my data. Create a table that points to it. That came back instantly because I didn't have to load data. The data is kept in S3. And this is the fun bit. I can then go out there and say, hey, please query some of the data. So this is saying, please go into my Elastic Load Balancer logs, add up the number of records that I had in the 1st of January 2015. And it goes across that data. It'll take about 20 seconds. And the really neat thing is it's just in S3. I didn't have to load it. So a great way to run across historical log information. Nato is asking, in RDS you get too many connections error. You solved it by scaling into a bigger instance. Is there a better way to solve this? Sometimes connection pooling, if a lot of your services like Lambda connect to a database and then disconnect, you might have a lot of connections that aren't being used, so connection pooling can help. But there is a limit to the maximum number of connections you can have on an RDS database. It's in the documentation, so a larger instance will help that. So check out, there's also a thing called RDS proxy, which we have, which acts as a proxy in front of the database and will handle a lot of that connection pooling for you. So check out RDS proxy, which might be of assistance to you. So here I have a query that's given me back all of my records. I've had, 9 million records go through there, and that took 20 seconds and it scanned 90 gigs of data, which is pretty impressive. But I mentioned before that you can compress some data. So I have another example here where I'm creating another table, and this time I'm pointing to files that are being compressed. I think they're compressed with gzip. And if I run the same query now across the compressed data, it'll still take about 20 seconds to get through because it's got to decompress the data and process. We should find that it has access to a lot less data on disks. So instead of reading through those 90 gig of data, the fact that it's compressed should lower the cost for us because Athena is charged based on the amount of data read from disk. So here it still took 20 seconds, but guess what? The amount of data read was only 13. So that's 14% of the cost. So you've really reduced a lot of costs simply by compressing data. But wait, there's more. There's a concept in Hadoop and other systems of partitioned data. And partitioned data means you have a directory structure that divides up. I'll give you an idea. You might have a directory structure that says, hey, I've got a folder for a year, I've got a folder for a month, a day, etc. And all your files relating to that day are stored within that directory. And the benefit of that is Athena, if it understands the way you've partitioned the data into folders, it only has to look at the folders that contain that information for that particular year, for that particular day, etc. And that can greatly reduce the amount of time that is required to query data. So I can come in here and say, please do a scan of the disk partitions that are out there. Because I loaded up the data, it's the first time I've seen it. It's saying, oh, I found all of these partitions. This month, this day, this month, this day, this month, this day. I can then run a query against it and say, please retrieve the same data as I was doing before, but where this is the year, this is the month, this is the day, which matches those folder names. That way it only has to go to that one particular folder of interest, and it should come back an awful lot quicker for us. Oh, okay, around about the same time in disk access. But what it's doing here is it's only scanned half a gig of data because it managed to skip over all of those folders. So again, we're paying even less. And as a last example, you can store your data in more efficient formats, such as Parquet. Parquet is a columnar data format. So if you're querying certain columns, the query engine can jump straight to where the data is stored within the file rather than having to read every column of every row like you would have to with a CSV file. And that makes it very, very efficient when you're just getting certain columns of information out. So for our last demonstration, I will select the same data off the Parquet file. And this should be more impressive. It took 2 seconds and only read 2 megs of data because it knew exactly where to jump to on disk. So, hey, Domination Games. What data sources does Athena support? It supports CSV, compressed. It connects. It supports ORC, Parquet. It supports various JSON formats. Athena. Oh, there's also a thing called Federated Query, which is mind-blowing. This allows you to also connect into Rds and Dynamodb and many other databases. So you can now perform a query across multiple databases and S3 all within the one engine. It's quite mind-blowing. Can Athena connect to Redshift? No. Well, yes. If you are using this new federated query, Athena can query Redshift, but then it's Redshift performing the result. Normally, Athena has its own query engine that it works on S3 on various data formats, but if you connect it to DocumentDB or RDS or Redshift, those services do the query, return the information to Athena, and Athena can then join it all together. So quite amazing what that can do. Let me also put that in the chat here for you. Ooh, too many things popping up. And Redshift Spectrum, I mentioned, is very similar to Athena. Redshift Spectrum can query things just like Athena, so many different options of what you can join within that. And one last thing I'll just squeeze in while we've got a moment in here. Not many people know about this. It's something called S3 Select. And you can have, is it this? Yes. In Amazon S3, S3 is just a simple storage service. You store an object, you retrieve an object. But sometimes you have a really big object and you just want some information from within that object. And S3 Select allows you to query within an S3 file, just one file. Athena can query across many files in parallel, so can Redshift. This is just for one file, but I can come in here and I have a file where I've got a listing of the tallest towers in the world. So the Burj Khalifa is the world's tallest tower. It has that many meters, that many feet, that many floors. And I can literally come in here in S3 and say, hey, please run an SQL query against this CSV file that might be compressed, stored in S3. So I could come in here and say, give me the name of something where floors is greater than 100. And I can run the SQL. Name where floors. Let's try country equals Australia. Here we are. So I've got all of the towers in that thing, in that database where they are located in Australia. So fairly simplistic. You can't do complex grouping and things, but a really nice way to extract data from archival files in various formats, CSV, JSON, Parquet, sitting out there in S3 without you having to load all those files into a system, do the query and throw them away. Just being able to run them directly against S3 is a very interesting concept in itself, and not many people know it exists. So, in summary, today we looked at RDS, good traditional database, MySQL, MariaDB, PostgreSQL, or Aurora, which can present itself as MySQL or PostgreSQL. Aurora has that amazing storage layer, which allows you to it replicates data across 6 storage units, can handle failures in AZs and machines, very fast to read, very fast to write, about 10 times performance. We also have that Aurora Serverless option, very good for automatically scaling up and down for bursty, intermittent workloads. I showed you Amazon Redshift, data warehouse where you have millions and even billions of rows and you're doing very intensive SQL queries across multiple tables. Really great for reporting systems. You can put your tableaus in front of it, for example. And Amazon Athena, a query engine running directly against S3. Fantastic for your data lake, where you have your data just stored in S3. No need to load it into a database, just perform your queries. Redshift has a similar capability called Redshift Spectrum, where you can join within Redshift. And a brief view of S3 Select, which is a feature of S3 that you never knew was there, where you can query data out of CSV and JSON files and Parquet files directly from S3. So hopefully that's given you an overview. As a developer, you would traditionally mostly be using RDS as your database, especially if you are migrating a traditional application into the cloud. But if you have the opportunity to re-architect or you're launching a new application, I highly recommend you look at Aurora for your needs. It's faster, probably a lower cost, easier for you to do things. Next week, if you join us at the same time, we will be looking at NoSQL databases, which includes Dynamodb and many other popular ones. My name is John. I'm a developer advocate with AWS in Sydney. Thank you for joining me. And if you're interested in those past episodes of this show, feel free to hop into, I'll put that back into the chat. I have created a library of previous Developers Let's Code episodes out here. We've had on such topics as storage, compute, the command line interface, security, light sail, creating dynamic and static websites. So catch up on that. Thank you very much for joining here, and we'll see you again next week. Cheers.